This is R.D. Sharma solution class 12 chapter 12 higher order derivatives. Exercise is 12.1. The next question is x equals 3 cos t minus 2 cos cube t. Y is equal to 3 sin t minus 2 sin cube t. We have to find out d2y by dx2. So we have x as 3 cos t minus 2 cos cube t. Now in order to find out dy by dx, we have to first find dx by dt and then dy by dt. So let us find out dx by dt. 3 cos t is minus sin t minus 2 cos cube t will be 3 cos square t and then cos t will be minus sin t. So I am making this as plus and a sin t. So dx by dt this is. So you can just write it simply like this: minus 3 sin t, 3 to the 6 cos square t and sin t. So I'm taking minus 3 sin t common because it is going to be used later on, and inside this you have 1. Here you have 1 minus 2 cos square t. So this 1 minus cos square t and 2 sin square minus 2 sin square t minus 1 will be cos 2t. You'll just see. So this I'm just writing as cos 2t. Actually it is negative, but I'll just first do the y part. This is y. Y is 3 sin t minus 2 sin cube t. So dy by dt will be 3. Sin t will be cos t minus 2. Sin cube t will be 3 sin square t. Sin t will be cos t. Differentiation of sin t will be cos t. This will be 3 cos t minus 6 cos t sin square t. Now I am taking 3 cos t common from here. So what do you get? 1 minus 2 sin square t. So please remember, cos 2 theta is cos square theta minus sin square theta, right? So cos square theta minus sin square theta. Cos square theta can be written as sin square, because cos square theta plus sin square theta is 1. So you can always write cos square theta as 1 minus sin square theta. So 1 minus 2 sin square theta is this cos 2 theta. But 1 minus 2 cos square theta or 1 minus 2 cos square t is negative cos 2t. Please remember. So in this dx by dt, we have minus 3 sin t and minus cos 2t, because 1 minus 2 cos square t is going to be negative cos 2t. And we know that this minus 3 sin t and minus cos 2t is going to be positive. So we have cos 2t, because cos square minus sin square is cos 2 theta. Same thing we are going to apply, and we just have to see one time we'll write cos square as 1 minus sin square, one time we'll write sin square as 1 minus cos square. That is how it goes. Alright, so we have these two things, dx by dt and dy by dt, and finally we'll find out dy by dx. This dy by dt I'm just taking this dx by dt and putting it in the denominator of what we found by dy by dt. So as I said, it is minus minus, it is going to be plus. So 3 cos t 1 minus 2 sin square t is dy by dt, and 3 sin t cos 2t is going to be in the denominator. So 3 cos t, and you know that 1 minus 2 sin square t is cos 2t only. We have 3 sin t here. This is also cos 2t. This gets cancelled. 3 gets cancelled. Cos by sine is cot. Cos by sine is cot. So dy by dx is cot t. Now we are going to differentiate it. So when we differentiate it, d2y by dx2, cot t is minus cos x square t. We already know that. But we just don't have to stop here. Minus cos square t, we have to include this dt by dx also. And dt by dx is just the reciprocal of dx by dt, which was already being computed. As you know that. Minus cos x square t, dx by dt is what? We already found out, this one. So I am going to take this in the denominator and try to find out how we can simplify these two. So minus cos x square t, here we have sin t, we have 3 sin t cos 2t. So I am writing it here in the denominator, 3 sin t cos 2t. Then this sin t goes up, already we have cos x square t. One more cosec goes up, means cosec square and cosec will be cosec cube t. Minus cosec cube t divided by cos 2t, and it is 3. So just include 3. And this is the answer. X is equal to a sin t minus b cos t. Y is a cos t plus b sin t. We have to prove that d2y by dx2 is this term, minus x square plus y square by y cube. Now there will be certain differentiation, but this is quite an easy differentiation, because when we do this a, x and y will definitely come again. I mean x and y, you'll just see x is equal to a sin t minus b cos t. Dx by dt is what? It's a sin t is cos t minus b cos t is minus sin t. So I'm making it as plus. And this dx by dt or dy by dx, all this we are going to use in just a while. So y we already know, it's a cos t plus b sin t. So it will be minus a sin t plus b cos t. Now dy by dx is dy by dt divided by dx by dt. So just relieving you from the different step of writing, I'm just putting this in the denominator. So dy by dx we have found out. So dy by dx is this term. Now we have to go for d2y by dx2. And since this is p by q form, we are going to apply the quotient rule here. So d by dx or dy by dx is d2y by dx2. Alright. So this is going to be differentiated again. D by dx or dy by dx. So differentiation of this, when you differentiate this, there is a t on the right hand side and you are differentiating with respect to x. So you have to include this dt by dx also. And dx by dt we already know, it's a cos t plus b sin t. So in order to find out dt by dx, we can have the reciprocal of this and multiply it with the final answer what we got or what we are getting in a while after d2y by dx, d2y by dx2. Okay. Please remember, whenever I'm writing, it's d by dx, but we are differentiating with respect to t. Okay, so this is, I'm writing in the short form, cos t as cot t, sin t as sin t. So this goes in the denominator. Now just put whatever is in the denominator like that, and now we have to differentiate minus a sin t plus b cos t. So minus a sin t will be cos t, and this will be negative. And I'm just, because I know that it is cos t will be minus sin t, so it will be minus b sin t. Now this is the first term being done in the numerator. Now we come to the second term, and since the denominator has to be differentiated now. So the numerator has to be kept like this as it is. The denominator has to be differentiated. So we're going to write minus a sin t plus b cos t, and differentiation of this. A minus a sin t because cos t is minus sin t, and b sin t is cos t. Okay. Now you can multiply anytime, but what I'm suggesting is, if you just see the intricacy, these things are nothing but what we have already. If you take negative outside, it will be a cos t plus b sin t, both the terms. So a cos t plus b sin t whole square, negative outside. Similarly here also, a sin t minus b cos t you need. So this is, if you take the negative common from both of these, you'll get a sin t minus a negative will be positive. It will be like this, okay? Minus a sin t plus b cos t whole square. And since, as I said, you can take negative from both the terms, multiply it positive, because minus will be positive. Or you can just take this minus a sin t plus b cos t, and because it is square, now you can take a negative outside, the negative whole square will be positive only. So finally you will get a sin t minus b cos t, and a sin t b minus b cos t is nothing but x only. So you have, as I said, negative you can take outside. When you take it as a square, negative will be positive, and this, it will be a sin t minus b cos t, which we already have, x. So first term was y, it will minus y square. Second term is x, so it will be minus x square. Denominator we have already y, so you can write y square here. Now this is not all, we have something else here. As I said, dt by dx also needs to be included. This dx by dt is already there with us. dt by dx is 1 by that thing, and 1 by that thing, which is a cos t plus b sin t, is nothing but y only. This is y only, so it will be y cubed in the denominator. So what do you get? d2y by dx2 is equal to negative, you can take outside, x square plus y square divided by y cube, y by cube, because y square was already there, and that is y one more we got from dt by dx. Okay, find a and b so that y equals a sin 3x plus b cos 3x satisfies the equation. So this dy by dx and d2y by dxt just has to be computed and has to be placed in this equation. And let us see what do we get. Y is a sin 3x plus b cos 3x. So dy by dx is nothing but a sin 3x is cos 3x, and 3x differentiation is 3 only. And since we have cos already, so I am taking minus outside. It will be b minus b sin 3x, so sin 3x differentiation will be 3. So 3a cos 3x minus 3b sin 3x. Now d2y by dx2, 3a cos 3x is minus sin 3x, and differentiation of 3x is 3 again. Here minus 3b sin 3x is cos 3x, and 3x is 3. So what do we get? Minus 9a sin 3x minus 9b cos 3x. So this is d2y by dx2 we have. So just put it here. dy by dx is also computed, and d2y by dx2 is already being computed. Now put it here. Alright. So just assume that we are starting from here. This is dy by dx2. I am adding 4 into dy by dx. Whatever is there, dy by dx, multiply it with 3 and then write it here. So 12a cos 3x, multiply again by 4. It will be 4 is 12b sin 3x and plus 3y. Y is a sin 3x plus b cos 3x. So it will be thrice of this. So I am writing it after multiplication, and this is equal to 10 cos 3x. Now take the sin 3x term together and take the cos 3x term together. So sin 3x, when you take outside, it will be minus 9a, then we have minus 12b and then 3a, minus 9a, and all the term with sin 3x I am taking together. Minus 9a plus 3 is minus 6a minus 12b. This is sin 3x. And coming to the cos 3x. So cos 3x, this is minus 9b. Here we have plus 12a and then we have plus 3b. So 3b minus 9b is minus 6b. You have 12a here. Write it as 12a and cos 3x is already there. Okay. Now this is equal to 10 into cos 3x. So when you equate it with 10 cos 3x, what does it mean? It means you have only the term 10 as coefficient of cos 3x and there is no term of sin 3x. So minus 6a plus 12 minus 6a minus 12b. So it is negative, sir. Remember, there is a slight thing which I am going to change. Is equal to 10. Minus 6a minus 12a is equal to 10. Minus 12b equal to this minus 6b plus 12a equals to 10. And minus 6a plus 12 minus 6a minus 12b equals 0. What I am suggesting is cos 3x and sin 3x. You just have to take the coefficient and equate. Only cos 3x has some coefficient, otherwise no. So this way of solving will not be possible. I am just writing minus 6a equals minus is plus 12b. So minus 6a is 12b. That means we have 6 to the 12. So minus a is 2b, so a will be minus 2b. Second equation is what? Minus 6b, actual equation actually. Minus 6b plus 12a equals 10. Minus 6b, and since as I said, this has to be written here because I am writing a as minus 2b, I am replacing it by that. So 6b minus 24b is minus 30b is 10, b is equal to 10 by 30 in negative is going to be minus 1 by 3. But a is minus 2 into b, so minus 2, b is minus 1 by 3, so minus plus 2 by 3. So a is 2 by 3 and b is equal to negative 1 by 3. This is your answer. Now y is equal to a e to the power minus kt cos pt plus c. There are so many constants here. Please remember t is not a constant because in the equation it is dy by dt, d2y by dt2. So t is x here. You can assume like that. So we can just call y equals a e to the power minus kx cos px plus c, and you have to find out dy by dx, d2y by dx2. Like that you can understand. Now at some point we are going to use p square plus a square as n square in order to find out this equation. Let us start here. This is the reference for you if you want to continue. I am solving it now. Y is equal to a e to the power minus kt cos pt plus c dy by dt is, so this t, as I said, you need to assume it like x because we are differentiating with respect to t. So a e to the power minus kt cos pt plus c e to the power minus kt, a we are going to use it just now. So I am applying the product rule. Cos pt plus c is minus sin pt plus c, then pt plus c will also be differentiated. This pt plus c is going to be p only. Then we have cos pt plus c. Now we are going to differentiate e to the power minus kt. It is going to be e raised minus kt. Differentiation of minus kt will be minus k only. Okay. So there are certain things which you can place here. We already have a here. Minus a e to the power minus kt cos pt plus c is already with us in the second term. Alright. This you can write directly as y. I am saying there is only k extra. So you can just write minus k. This whole is going to be y. So minus ky, the second term. What about the first term? Minus a, this as I said p, I am bringing it in the front. So minus pa e to the power minus kt pt plus c. This is dy by dt. This is the way, or you can just d2y by dx2 here. And again the same thing is going to happen. There will be term which can be easily counted for y. I mean replaced for y. So d2y by dt2. This is I am writing d2y by dx2 plus, but you need to understand I am not writing it. I am just trying to explain that this is nothing but d2y by dt2 only. So minus k dy by dt. This was already there. Minus ky I differentiated. and minus PA e to the power minus KT PT plus C, I am doing it separately. Minus KY differentiation already being done, the second term, minus K divided by dt. So this e to the power minus KT minus PA I am going to include just now. This term was what? So this is sine. So I just left this sine, so I am writing it again. So e to the power minus KT, sine content will be cos content, and PT plus C differentiation will be P only, plus sine PT plus C will be like that, e to the power minus KT will be e to the power minus KT, and then differentiation of minus KT is going to be minus K. So what do we get? E to the power minus KT cos PT plus C, P is already there, and remember minus PA I have not written, it will be multiplied just now. Minus PA is already there, so I am writing the other terms here. Minus K to the power minus KT sine PT plus C, minus PA is already there, so need to multiply here. So multiply it here. I am saying we are multiplying the first term and the second term with minus PA. It will be P minus P square, then A was already there with multiplication, e to the minus KT cos PT plus C. Here also minus PA we have to multiply, minus will be plus, we have PA K e to the power minus KT sine PT plus C. Right? Minus K divided by dt with this term. This is the term we got after differentiating minus PA e to the power minus KT sine PT plus C. Let us see, minus P square Y, because this whole term is as we just did few seconds ago. So this can be replaced as Y, and this whole, please remember dy by dt was what? Dy by dt minus PA e to the power minus KT sine PT plus C, and we already have it. So PA e to the power minus KT and sine PT plus C. Only K is not there, otherwise everything is there, right? So we are going to write minus KY and K divided by dt. So if you multiply this Y, the first term, that is if Y equal to this, both sides with K, KY equals to KA e to the power minus KT cos PT plus C. So you can just replace it by K. PA e to the power minus KT sine PT plus C. So this whole one is what? We already done this. This is minus KY minus dy by dt. So just for this, because dy by dt is already been computed, you can write it as minus KY minus dy by dt. So minus P square Y was already there, and there is K multiplied. So I am doing it as K square and K. D2y by dx2, this whole is there, and as I said, this minus K dy by dt was already there. So this is also there, so it will be, there is already minus K dy by dt here. So minus K dy by dt twice is minus twice K dy by dt. So minus K dy by dt two times this whole, minus 2 K dy by dt. We have here minus P square Y minus K square Y. Let's just write it as minus, if you take Y common, it will be P square plus K square. But in the question it is already there, P square plus K square is equal to N square. Yes or no? So we can write it as N square. So minus 2K dy by dt minus, this is N square Y. N square Y, we have d2y by dx2. And this, all of the term on the left can be taken on the right, on term can be taken on the left. d2y by dx2 here, minus 2k dy by dt minus final term will be d2y by dx2 plus 2k dy by dt plus n square y equals 0 after replacing p square plus k square as n square. So I am writing the final term here, this term plus n square y equals 0. This is your answer. So this is the way you have to do it. Okay, this is all about this exercise. Thank you so much. Take care of yourself.